Okay, you probably know what synoptic events are. In this case, we are going to just focus on the so-called low pressure systems, which have a minimum wind speed of about 8.5 meter per second, and they range up to 16.5 meter per second. Of course, when they reach 17 meter per second, they become tropical cyclones, and there are occasional examples of tropical cyclones during the monsoon season, which, because of this very strong vertical shear, doesn't favor tropical cyclones. There is a pre-monsoon cyclone season and a post-monsoon cyclone season. But in the context of this monsoon intraseasonal oscillation lectures, podcasts, we are going to look at whether ISOs or MISOs can cluster synoptic events. Obviously they can. You can see here tracks of low pressure systems for the period of 1954 to 1983 during the extreme phases of monsoon ISOs, so during the active phase and during the break phase, so active period, break period of the Indian monsoon as defined by the core monsoon zone, the definition we have seen before. So the monsoon ISO phase index used here is the 10 to 90 day filtered relative vorticity during the summer monsoon season, averaged over 80 to 95 degrees and 12 north, 22 north, which is basically Bay of Bengal. Dark dots represent the genesis points, and the lines show their tracks. And so you can see that there are lots of genesis happens here in the northern Bay of Bengal, and they all trek along the monsoon trough into the core monsoon zone. And there are periodically some that are being born in the Arabian Sea side. During the break, the big difference is that there is not a very well clustered location of genesis. So on both the Bay of Bengal side, the Arabian Sea side, and the Himalayan foothills, there are some low pressure systems being born, but the number is drastically different. In this study by Goswami et al., they claimed there is more than 3 times the number of low pressure systems being born during the active period, and we know that the active periods are associated with the northward propagating systems coming up here into the Bay of Bengal. Okay, so there is obviously an impact on intraseasonal oscillation on the clustering of synoptic events, and the convective activity that's typically associated with the intraseasonal oscillations or MISOs coming up provides plenty of cyclonic systems at the surface which can grow into low pressure systems. There's a very nice study by Krishnamurthy and Ajay Mohan from 2010 which did a very detailed analysis of a very long period from 1888 to 2003, and you can see the genesis shown here by red dots and the trajectories with the blue dots and the terminations with the black dots. It's quite much more comprehensive than what we saw here, and they identify 1,520 low pressure systems with a total of 6,841 low pressure system days, how long they lasted after they were born. So you can see that the average life cycle is almost 4 times or 4.5 times here in 4 days or 4.5 days in this analysis. And we have said many things about 10 to 20 day time scale, 30 to 60 day time scale intraseasonal oscillations. We talked about wet years maybe being dominated by 10 to 20 day time scales, dry years maybe being dominated by the 30 to 60 day time scales, and if there is a clustering of the synoptic activity by the intraseasonal oscillations, and these LPS systems bring up to 60% of the rainfall during the season, so there must be a relation between the wet years, dry years, and relation with El Nino, which causes droughts and floods over India, and so on. So these kind of things are not completely resolved, but you can start with this one where you look at the low pressure system days and correlation with the El Nino index, Nino 3.4, which you can look up or listen to my other podcasts in other courses. You can see that the relation is basically 0 or even slightly negative, which means that the synoptic days, synoptic events may not be highly affected by El Nino. So what could be? If you look at the OLR LPS composites and non-LPS composite, you see the expected structure. Those kind of synoptic activities and the northwestward propagation are also likely to be related to the 10 to 20 day time scale, just saying, which has the northwestward propagation, but it's the 30 to 60 day band that has this kind of large dynamic structure extending from the Northwest Pacific, tropical Pacific into the Northwest Indian Ocean. If you remember, the 10 to 20 day bands had a very small zonal structure. So the opposite phase in OLR occurs. So this is the minimum in OLR, which is the convective phase, and the maximum in OLR anomalies, which corresponds to the dry phase, which is expected. If you look at it monthly, June has 327 LPSs with 1273 LPS days. July has slightly more, August has somewhat similar, and September the number of LPS drops and the LPS days drop as well. And in terms of seasonal evolution of rainfall, we know that June is when the onset typically happens. June rainfall contributes only about 20% to the seasonal total. July, August are the peak season in terms of total amount of rain contributed, and September is when the withdrawal happens. But in terms of interannual variability, often it's September that tends to control the interannual variability in terms of anomalies. So you can see that the clustering of LPSs, there is more on the Arabian Sea side here compared to the other months, maybe also in the withdrawal phase. It's not so well organized here, much more well organized here, and here not so well organized here. So there are all kinds of signatures of synoptic activity and the clustering in the monsoon season in each month. How these are related to the MISOs has to be looked at. This study just focused on LPSs. So we need to connect MISO activity by months and their impact on clustering. Excuse me. And the net impact on monsoon seasonal rainfall. So if you look at the flood years and drought years, surprisingly corresponding to the El Nino type relation, you see not such a significant relation. Flood years have in fact fewer low pressure systems compared to drought years, but flood years have more systematic evolution over the Bay of Bengal and longer tracks and not so many more LPS days, but on average you can see these tracks here from birth to demise are longer. Whereas here the genesis region is much less organized, corresponding to the total number of LPS systems, synoptic events. Obviously there are more LPS days, but the relation is not so obvious. So some kind of consistency has to be explored in terms of MISOs, LPSs, floods, droughts, external forcings, not only from ENSO but also from the Indian Ocean dipole, Atlantic Nino, and so on. In fact, there is a paper by Pattapinjara et al. From 2014 which shows that the so-called Atlantic Nino, an El Nino-like climate mode in the tropical Atlantic, which happens during June, July, August, when it has a warm phase of Atlantic Nino, the number of LPSs is greatly reduced and the monsoon experiences a drought. So there are also Atlantic Ninos happening when there is no Pacific Nino. So that has to be looked at more carefully as well. Indian Ocean dipole typically peaks in September, October, November. So even though El Nino peaks in December, January, February, the strong events are evolving during the summer months, 6 months before when the monsoon is happening. So we know that El Ninos can affect the monsoon and can modulate interseasonal variability as well. But of course, we already said that only 50% of the droughts are explained by El Nino and only 50% of the floods are explained by La Nina, and the correlation between LPS days and Nino 3.4 is basically non-existent. Okay, so all these kinds of things have to be considered, and there is the other question of whether synoptic events can modulate intraseasonal oscillations, and there is some recent work that talks about mixed Rossby gravity waves related to tropical disturbances, which seem to be able to modulate intraseasonal oscillations. Intuitively, we would think the upscaling from the synoptic events to the intraseasonal timescale is not going to be very robust, but obviously this is another open question. So synoptic events are heavily clustered by the interseasonal oscillations, but the relation remains kind of fully to be understood. But what is clearly understood is that active period of the monsoon has a large number of low pressure systems, and the break periods have fewer disorganized low pressure systems, and the active break periods are very strongly related to MISOs, so there is clearly a clustering of synoptic events by MISOs. Okay.